Hi there, and welcome to another Papetti Math YouTube video tutorial, where I'm going to be teaching you Algebra 1. And in this video, we're going to continue on with our final two exercises in Lesson 2 on solving systems of equations by substitution. And it says up top, in each of the examples in this lesson so far, you have successfully solved a system of equations using the substitution method and obtained a rational solution. Now we are going to look at various types of solutions you may also encounter during your study of Algebra 1. So let's take a look at exercise number 4, where it says solve this following system of equations using the substitution method. So we know our y value here is x plus 3. So I'm going to take that y value, and I'm going to substitute x plus 3 into y in our second equation. So this value is going right there. So I have negative 3x plus 3 times, x plus 3 is equal to negative 3. And I'm going to have negative 3x, distribute the 3, I'll get 3x plus 9 is equal to negative 3. And now when I combine my like terms, I'm going to have, wait a second, I'm going to have nothing left. I'm going to have 0x plus 9 is equal to negative 3, but 0x is the same as 0, and 0 plus 9 is equal to negative 3. Is 9 equal to negative 3? And the answer is no, 9 is not equal to negative 3, so we say that this has no solutions. If you ever encounter an equation or a system of equations where one number is equal to another number, or one constant is equal to a different constant, there are no solutions. But now let's look at how that looks like on a graph. So let's start off by graphing the equation y equals x plus 3. So we're going to graph y equals x plus 3. That has a y-intercept of 3 and a slope of 1, because there's a 1x right there. So that's up 1 over 1, up 1 over 1, up 1, right 1, up 1, right 1, for as far as we could go in both directions. Okay, once we get all of the points that fit on our coordinate plane, we're going to connect those straight as possible. And let's put arrows on it. And now we're going to label that as y equals x plus 3, so we don't forget. Now, before we could graph this equation over here, we're going to have to isolate y. So I'm going to isolate y right on in this box right here. Negative 3x plus 3y is equal to negative 3. And let's isolate y by first adding 3x to both sides. Let's be left with 3y equals, I'll put my x's first, and I have 3x minus 3. And I'm going to divide both sides by 3, and I will be left with y is equal to x minus 1. So I have y equals x minus 1 here, and I'm going to graph that line. That's going to have a y-intercept of negative 1 and a slope of up 1, right 1, up 1, right 1. So I'm going to graph that slope throughout the entire coordinate plane. And as you notice, as I graph those points throughout the entire coordinate plane, what do you notice about the two lines that are being formed right here? You should notice that these two lines are parallel. Yes, awesome. So these two lines are parallel. And where will two parallel lines intersect? And great, so two parallel lines will never intersect. So remember, when we solve systems of equations, we are looking for the point at which the two lines will intersect. Since parallel lines will never intersect, that's why we're going to get a funny looking solution right here, which means no solutions, because there are no solutions where these two lines will ever intersect. And if this video was helpful in finding the intersection point of two parallel lines, which comes out to no solutions, give this video a thumbs up and look at one more funny looking scenario in exercise number 5 in the next video. Thank you for watching.